Hello class, it's Mr. Kaplan here again. I'm here to present the next lesson here in chapter 7 that's going to deal strictly with the angles pertaining to triangles. So let's get right to it. And remember from the last lesson, we were introduced to some of the key terms that we're going to be seeing in this chapter, and the two terms that you're reintroduced to were acute and obtuse angles. So remember with triangles, especially right angle triangles, what you would have there is that if you have angles in a triangle that are less than 90 degrees, that you would have an acute angle triangle, and then if you have angles that are beyond 90 degrees, you would have obtuse angles inside those triangles. Now, in today's lesson, we'll be looking at not only just angle relationships inside triangles, but also outside as well. Okay, so that's what we want to look at, as well as other relationships dealing with triangles. So let's start off with a nice little introduction here. So when we're looking at the outside angles of the triangle, and this is the part that's relatively new for you, is that when you see a triangle and you extend the sides there, the outside angles add up to 360. So if you take a look at this diagram here, and the outside angles being x, y, and z, okay, when you add up these three angles, they will add up to 360. Okay, you should know that inside the triangle, the three angles add up to 180. So just notice those two different numbers there. Now, what's going to be different here? Okay, is this now you have to understand that when we're dealing with triangles, there is a relationship that exists between an outside angle, okay, and the inside angles of a triangle. So when you're looking at an outside or exterior angle of a triangle, okay, the exterior angle is the result of adding the two angles on the opposite side of the inside of the triangle. Okay, so if you're taking a look at angle A, this angle here, this outside angle, okay, if you add up the two opposite angles inside the triangle, they would give you that measure there. Okay, so that's going to be also a new little a new thing that you're going to see in today's lesson. So when we're looking at triangles, there's that relationship that exists, and that's also going to be all around the triangle as well. All right, so let's see some numbers, and let's start off with this one here. And there's going to be some questions in this particular lesson. You're actually going to see two different ways to solve for it. So in this is actually one of those questions. So the first way we're going to do it is we're going to solve for the inside angle first. Okay, I tend to call this step here filling in the gaps, because as much as possible, get as much information as you can before you actually start solving for the rest of the problem. Okay, so the way we're going to do that is, remember I mentioned in the beginning of this lesson that all three angles inside the triangle add up to 180. That's exactly how we're going to solve this problem. Okay, so we're going to take those two angles that we have there, okay, and we're going to add those two angles up, okay, and then subtract them from 180. Okay, so when we do that, okay, that gives us a value of 65 degrees. Now, the reason why I've done it this way is because we're going to solve all three angles, angle A, angle B, and angle C, using supplementary angles. Because remember that anytime you see two angles that form a straight line, okay, they add up to 180, and then you can solve for them simply just by taking that value and then subtract it from 180, and that's exactly what we're going to do for this one. So for example, for angle A over here, okay, all we're going to do here is subtract 65 from 180, because A and 65 degrees form supplementary angles. So we have a measure of 115. Okay, same thing with angle B. All we're going to do there is to take the 40 degrees and subtract it from 180. Okay, and that gives us 140. And last but not least, we're going to take the 75, subtract that from 180, and that gives us 105 degrees. Okay, so that's the first method. Okay, so again, what you can see here, you solve for the inside angle first. Okay, and then from the then you would solve for all three exterior angles there using supplementary angles. All right. Now, the second method will have the first step as the previous example. We're going to fill in that gap there again by taking the 75 and the 40, adding them up together, and subtracting them from 180. Okay, so that part, I've just repeated that step here. All right. Now, what we're going to do here, we're now going to solve for the outside angles, okay, using the inside angles that are on the opposite side of that outside angle. So I'm going to outline the first step here so you can see how we would do that. Okay, so for angle A over here, what I'm going to do for angle A is I'm going to add up 40 degrees and 75 degrees. Okay, so for that one there, you're going to see that to solve for angle A, I'm just going to add those two angles there. And guess what? We wind up getting the same answer that we did in the previous example. Okay, now if you take a look at angle B, okay, remember that to find the measure of the outside angle, you add up the two inside angles that are on the opposite side of that. So if you look at angle B here, you should see that 75 degrees and 65 degrees are those angles. So when we add those two angles together, okay, that gives us 140 degrees, which again is the same measure that we got in the previous example. All right. And last but not least here for angle C, okay, if you look on the in the inside of the triangle on the opposite side there, okay, you're going to see that what you have there's 40 degrees and 65 degrees. You're going to add those two, and that gives me 105 degrees. All right, so you notice I presented to you two different methods to solve the same type of problem. Now, again, in terms of terms of this, you're not always going to have all three angles there. That's why that's why it's important that you understand how this relationship works, because quite often, and you're going to see this in your package as well, is that you're going to see some questions where you only have the outside angle, okay, and the two angles on the inside the triangle on the opposite side there. Okay, so you do need to know that relationship. Okay, so again, with this particular method, just know that the two angles inside the triangle that are on the opposite side of the on the outside angle there, okay, they when you added them up, they will equal that outside angle. All right. Okay, let's take a look at another example here. And this time we're now going to look strictly at the outside angles. So we have the V, the 97 degrees, and the 103 degrees. Now I am going to present this two different ways, which I'm just going to nickname. And just remember, with exterior angles for triangles, okay, it's no longer 180 and it's going to be 360. Okay, so that's the number that you have to remember for the sum of the outside angles of a triangle. Now, I want to do this a long way first, just to show you that you do need to know the relationship, how to set up this relationship between these three angles and how they add up to 360. So notice what I've done here is I've used the definition of that to set up the equation. So what I have here is V plus 103 degrees plus 97 degrees equals 360. All right. So next thing I'm going to do, I'm going to add up these two angles, okay, which gives me 200, and then take that 200, okay, move it to the other side and subtract it from 360. So we have an angle V of 160 degrees. All right. Now the short way, believe it or not, is exactly the same thing. Okay, and it's just basically adding the two angles first and then subtracting it directly from 360. Okay, so you can see that you can do it like this. Now, with a scientific calculator, you can actually solve for it from that step if you put it in exactly the way you see it. So you can try this if you want. If you punch in 360 minus and in brackets 103 plus 97 and close the brackets, okay, as long as you put it in correctly, you will get the answer that we see here. If not, you can just break it down accordingly. So when I add up those two angles, we get 200, and then we subtract the 200 from 360, which gives me 160 degrees. All right, so those are just the two ways that you can solve for that particular problem. All right, so the next thing we're going to do here, we're now going to look at the exterior angles of an equilateral triangle. So remember in the introduction, we were working on a problem, an isosceles triangle. Well, with the equilateral triangle, what you just need to know about that is that all three sides are going to have the same length. Now, in a triangle, not only will all three sides have the same length, but all three angle measures will also be the same measure. All right. So what we have to do here again is we actually want to solve for the exterior angle for this particular equilateral triangle. Okay, and we're actually going to look at this two different ways as well. Okay, so the first method, we're going to use the interior angles first. Okay, and you know, with the inside angles of a triangle, okay, they add up to 180. So we're going to solve for this algebraically because I want you to I want you to be accustomed to using variables to solve for unknown quantities. So we're going to do exactly that. So the way we do this again is we're going to let each angle here be x. Okay. Now remember, inside the triangle, all three angles add up to 180, and we're going to set it up exactly the way that I just said there. So that means I'm going to take the three x's, add them up to equal 180. Okay. Now in this case here, when we add up the three x's, that will give us 3x. And last but not least here, we would need to divide both sides here by 3. Okay, and that would give us a total here of 60 degrees. All right, so that's step number 1. Okay, so each of these 3 angles are 60 degrees. Now, for all 3 angles, okay, remember that all 3 angles now, all 3 exterior angles, okay, we know that the exterior angle and the 60 degrees for each of those corners are supplementary. Okay, so what we're going to do in our final step is we're going to solve for it by subtracting 60 degrees from 180. And since all 3 angles will be the same, we only have to do this one calculation. Okay, and the way we do that is to take the 60 again and subtract it from 180. So each of these exterior angles will be 120 degrees. All right, so that's one option. Okay, so and you notice in this one here, we had to solve for the interior angles first, then use supplementary. So technically we had to do two different calculations there. So the next one, we're going to strictly use exterior angles, and we're going to use the definition of the sum of exterior angles for us to do that. So we know that all 3 angles, okay, the 3 x's that I have here, when we add those 3, they add up to 360. Okay, so in this one over here, we're going to take the 3 x's, add them all up. Okay, and from there, that'll give us 3x equals 360. And last but not least, we divide both sides here by 3. Okay, and that will give us a measure of 120 degrees. So that tells us that all 3 angles will be 120 degrees. So as you can see, when you're using the exterior angles only, okay, you only have to do one set of calculations. All right. So that wraps up angle relationships and triangles. So our next lesson is going to be dealing with quadrilaterals, and we're going to approach it in a very similar fashion as we did in this lesson. So until then, see you next time.